software, so that's why it's a little different. Are we ready?
You're out of camera. That's about it.
I'm out of camera? Okay. Is that better?
There you go.
Okay. All right. Can everybody hear me okay? All right. Well, good evening, everyone. Thank you all for attending. My name is Anurup Joseph. I'll be presenting tonight on XP. The topic is thriving among constant change. And why that topic is relevant is because in our field, most of us deal with constant change. And therefore, being able to adapt to that change and being able to manage it is an important part of our job. And if we learn to not just manage it, but learn to thrive in it, then we can excel at our jobs. And so what I'm going to talk about is, just before I get too much into it, just a brief background. Paul already talked about this before. And for those of you who attended my session exactly a year ago, just briefly, I've been coding since '83, coding professionally since '94, in Java since about '96, '97, enterprise Java since '99. I've worked in different industries from telecom to hardware to entertainment in different geographies like the Midwest, Silicon Valley, and up in LA and down here. Exploring is just part of who I am. I was born on one continent, my sister a second continent, my family settled on a third continent, all by the age of 6. And so travel just came naturally to me, and so I just love to see the world and explore it. And I also explore intellectually as well. So I'm just really curious about new trends in our industry, where our industry is going, and to try to see how that can benefit us. And they always say, you only know something if you can share it with others, if you can teach it. And so I like to present to others because not only is it a way of sharing with others of knowledge that I think is helpful, but also it's a way that I basically get to make sure that I understand it, because you have to be able to understand it to be able to distill it in a fashion that others can understand. So specifically, I lately been like to work with Agile philosophies and methodologies, as well as continuous integration, continuous delivery. As Paul mentioned, I spoke last year on continuous integration, and perhaps in a little while, in a few months or so, I might speak about continuous delivery as well. Now, let's talk about you specifically. I want to tailor my topic to the audience. I want to tailor my talk to the audience. So can we have a show of hands? How many of you work in environments or projects or companies where you practice waterfall development?
Historically?
No, in your current projects. Okay, so we have one person still in waterfall. Okay, so I feel your pain. No, I understand. How about folks who work in Agile environments? Okay, so a good majority of you work in Agile. All right. Anybody work in something completely other? Anybody work in chaotic environments where there's no process whatsoever? All right, we got a few people in that. All right, great. And then have anybody who are working in Agile, are you specifically following some of the Agile methodologies such as Scrum? Anybody working with Scrum? Okay, great. Anybody working with Kanban? Okay, so about half the amount. Anybody heard of Scrumban or working with that?
Heard of it.
Okay, heard of it, all right. Anybody heard of or working with XP?
Heard
Okay,
of it.
heard of it. Anybody working with XP? Oh, all right, great. So got 3 people so far. All right, so that's good. This means that I basically can gloss over much of the introduction to Agile, because it sounds like most of us already know Agile. I'll just speak briefly about it, but I can not have to bore you with talking about why Agile was created and so on. And then we don't need to go into these methodologies, Scrum, Kanban, and Scrumban, because I had these as appendices in case we wanted more detail. But we can shelve that and go right into XP. Okay, so our agenda would be talking about Agile, the 4 values and the 12 principles. As I mentioned, because we are mostly familiar with it, I will kind of gloss over it and not go into too much detail. Instead, we're going to go into XP, which is an implementation or a practice or a set of methods used to practice Agile, and talk about its history, its practices, the rationale for why we would do that, as well as some best practices and what we can hope to gain from that. Before we go any further, if anybody has any questions, of course, feel free to raise a hand, interrupt me, no problem, we'll take care of that. And in terms of logistics, what I'm hoping to do is to get as close to around 7:50, 8 o'clock as possible with the presentation, and then after a short break, we will then get into maybe giving a live coding demo, and hopefully if the demo gods are with me, everything will work okay. So we'll see how that goes. All right, So let's first jump into Agile. Again, just a brief talk about why that's important. Agile came about because in the days of waterfall, the whole idea was that a project's requirements were knowable in advance, in complete detail and in full comprehensive fashion. Everything would be documented heavily. You're shaking you're nodding, so I understand. Yeah, the idea is everything is knowable in advance, everything is documented, you have the full requirements, and you have the traceability from the requirements to the architecture, to the design, to the implementation, the interface control documents, to the test cases, to the test suites, and everything so that you can trace it all back to the requirements. And it sounds great in theory. In practice, what happened over and over and over again was that very often, no matter how professional people were, no matter how thorough they tried to be, no matter how well-intentioned, almost always, we never got all the information about what the requirements were of a project before the project started. And more importantly, even if we did, things would change over the duration of a project. And in the old waterfall days, any changes that came in were extremely expensive and required a whole lot of bureaucracy and ceremony in order to handle. Things like a change control board, a change request that goes to a change control board that approves it and tries to budget for it and tries to say yay or nay, and how much would that blow up the schedule, how much more money would that cost. Anyway, it was kind of a convoluted mess. And so in 2001, I believe, yeah, February 2001, in a Utah resort, I believe called Snowbird, 17 software expert practitioners came together to discuss a better way. They bounced ideas off each other, they argued, they debated, they held forth discussing and talking and brainstorming, and they came up with the Agile Manifesto, a set of values and principles that they felt would lead to a better form or a better way to develop software. And it has 4 core values. And these values are, this is better than this, meaning Agile favors individuals and interactions over processes and tools. Not to say processes and tools are not important, but that individuals and interactions are so much better. In other words, instead of describing in incredible detail every process, every contract, we instead just go to a person and talk. What is it you want? How can we get that there? What about this idea? We favor working software over comprehensive documentation. Rather than writing reams of documentation that often is obsolete the moment it's written, we rely on working software. Comprehensive documentation has value, working software has more value. We'll get to that in a little bit more when I talk about TBD. And customer collaboration over contract negotiation. Ceremony in the old days called for precise customer documentation so that the customer could never be mad at us because it's all documented. If the customer said they wanted an extra feature, we could go back and say, see, you didn't mention that in the contract, we're okay. But that leads to an often antagonistic or non-productive relationship with customers and developers. Instead, what if we collaborate? What if we communicate frequently so that if the customer has a requirements change, we're aware of it, we adapt quickly and communicate with the customer so that they're part of the process instead of feeling that they're a victim of the process. Makes for a much more better working relationship. And lastly, responding to change over following a plan. Following a plan is great, but you know what they say in the military? No plan survives contact with the enemy. Meaning, reality gets a vote. And oftentimes that vote is, ha, nice plan, sorry, it's not gonna work. In other words, you can plan as well as you can, but random chance happens. Changes happen. And because of that change, following a plan blindly to the death is not as valuable as pragmatic as responding to change, because change, literally, is the only constant in life. And that led to a set of 12 principles. Again, I'm not going to go into this in detail, but the principles basically are early and continuous delivery of software. In the waterfall world, sir, you said you would follow waterfall. About how often do you release software? Is it every year?
Once a month.
Once a month?
At least.
Oh, okay, all right. That's actually pretty good for waterfall. Because when I worked on waterfall, the idea was we release once a year. Which, if you think about it, by the time you release, oftentimes the business requirements have radically changed. And so, you know what, yes, I'm hearing some nodding over there. So yeah, Agile has a principle of early and continuous release of software, delivery of software to the end user so that the end user is aware as soon as possible. Because of that, Because of that, we welcome changing requirements. Even while we're developing, it's okay. We welcome change requirements because that's part of life. We're going to deliver that software frequently, right? We're going to favor weeks over months. We're not going to deliver in 6 months. We would rather deliver in like a week or 2 weeks and continuously deliver over time. And of course, this requires close daily communication and cooperation between business and developers, right? The business defines the job well done. They're the people who say, yes, this is what I wanted, or no, it isn't what I wanted. And I'd rather find out right away rather than 6 months later if I'm not doing what they wanted, right? And so we want to build the projects around a motivated team of individuals. Agile requires, and this is an important thing, guys, you cannot get a bunch of uninterested people, unmotivated people, throw Agile over it, and hope for a successful project. It's not going to work. You require a committed group of motivated individuals to do it. If you have a committed group of motivated people, Agile empowers them. And you can then trust them to do the job well. That they can be trusted to do the job well. They don't need to be micromanaged by some manager with a 2,000-point checklist. And so the best communication, again, is face-to-face conversation over detailed contracts. And so how do we measure our progress when we're doing this? Not with checklists, not with documents, but with working software. We deliver working software. And therefore, we promote sustainable development. The one thing about Agile that one thing about Waterfall that always bothered me was that because things changed so much, the deadline never did, and so it always resulted, almost always, in a death march at the very end. You got to work 7 days a week, you got to work 12 hours a day just to make this deadline. Even though things changed, we still got to make the deadline, and so Agile says, no, we're not going to do that. We're going to promote developer welfare by promoting a sustainable pace. A sustainable pace means no overtime. We're going to do this normally, like a human, rather than requiring superhuman efforts, rather than requiring super heroic efforts. We're going to do this normally. And so it requires that motivated team of people to focus on tech excellence, good design, and simplicity, meaning we need to maximize the work not done. We're not getting paid by lines of code. We're getting paid to do the job the customer wants, and that means doing exactly what they want and trying not to add additional stuff because we think in the future it might be relevant. You'll see why later. The philosophy is you ain't gonna need it, basically, right? And the best architecture, the best requirements, the best design, all that comes from self-motivated, self-organized teams which continuously reflect, adjust, and improve upon all their processes. Okay, so what does that mean? That means if you follow those 4 Agile values, if you follow those 12 Agile principles, you are Agile. There are many methodologies in Agile. There are many methodologies that are Agile, such as Scrum, which many of you said you follow. Kanban, which several of you said you follow, and Scrumban, which at least a couple of you said you at least have heard about. Okay? We're going to talk, and there are again many more, but tonight we're going to talk about one particular methodology that is Agile because it follows those values and principles, and it's called XP. What is XP? Okay, XP is an acronym for Extreme Programming. The idea is let's take a best practice, let's take it to something that we all agree is a good thing, and let's take it to its logical conclusion. Let's take it to the extreme, because if some of a good thing is a good thing, then a lot more of a good thing is probably better. So it takes best practices to their extreme. And it was created, this concept was created in the late 1990s by a very important computer scientist named Kent Beck. He's a luminary in the field, and he's created a lot of things that we might not be aware of that he's created. Anyway, he created XP while working at CCC, which was a Chrysler Comprehensive Compensation Project. It was a payroll project at the Chrysler Automobile Company in Detroit, Michigan in the late 1990s, and Kent Beck led that project, and he decided to put these practices, he experimented with these practices, found that they worked, and put it together as a comprehensive solution called XP. Now, Kent Beck, he's kind of interesting because not only was he one of the 17 signatories of the Agile Manifesto back in February 2001 at the Utah Resort, but he also was the creator, or as he himself calls it, the rediscoverer of TDD, test-driven development. We'll get to that later. He's also, if you've heard of software design patterns, he's also the co-inventor of the concept of software design patterns. So he's really done a lot for the field. And he was a big Smalltalk proponent and created a forerunner unit testing in Smalltalk, that was a forerunner to all of the NUnit or the XUnit packages, such as JUnit, that most of us Java developers are very aware of. Exactly, there you go. So Kent Beck has really given a lot to the community. Agile Manifesto, test-driven development, software design patterns, JUnit, and again, especially extreme programming. Let's talk about the values that XP has. XP talks about communication, frequent communication. In fact, almost constant communication. You'll see what we're talking about when I get into pair programming, one of the practices of XP. Simplicity, you ain't gonna need it. That's that acronym, YAGNI, you ain't gonna need it. Basically in XP, the idea is you define what the program should do or what the application should do, you code just enough to get it working, then you move on to the next requirement. Just enough to get it working, and you move on to the next requirement. The idea being, you just do what is necessary to get the program working. You don't do extra work that is not going to be used, because most likely it's not going to be used, and you don't create extra maintenance headaches for yourself later because you overly complicated the interface or overly complicated the functionality or the working of the actual algorithm. Relies on constant feedback, right? Constant feedback in the sense of your peer or your pair programming with you and giving you feedback as to the code that you both are developing. Constant feedback from the customer who's partnered and embedded with you, telling you, hey, yes, this is exactly what I, the customer, want, or no, this is totally off base. Let's turn that off right now, right? So you get that constant feedback, and you got the courage to design code for today, not for some imaginary far-off future where we think some functionality or something might be required. And lastly, respect. Not only respect for oneself, because we want the sustainable welfare, the sustainable pace, respect for our peers, and that we don't expect from them what we won't do for ourselves, respect for our peer, that we respect their viewpoints, we respect their ideas. When they communicate with us while we're pair programming, we hear them out and we understand and accept their feedback. But also respect for the field of software engineering, that we always want to read up on new techniques, new methodologies, and implement them so that we're continuously improving as a team. All right. Now, XP, unlike all the other methodologies, almost unique amongst all the Agile methodologies, XP actually prescribes practices, meaning actual set of behaviors. Scrum, Kanban, Scrumban, they don't say exactly how you should program. XP actually does. XP actually suggests how you should do certain things. So the others suggest meetings. For example, Scrum talks about a daily stand-up, right? So XP not only talks about that, but also says, here's how you should program. So we talked about the values before. How are they implemented in XP? Right here. Feedback. Well, you can get feedback from pair programming. Why would we pair program? Well, think about a code review. Why do we do a code review? Well, for many reasons. The principle of science, one of the things we do is peer review, right? When a scientist publishes a paper, that paper is peer reviewed by other experts in the field who say, oh, okay, this makes sense, or oops, you made a mistake, or you've overlooked something. It's great to get feedback from our peers so that we haven't overlooked something or that we are actually delivering something of value. Now, if that review is important, also consider our normal practice when it happens. I like to use the analogy of a party. If I'm having a party at my house, what room am I going to make sure is really clean and well maintained? Is it the living room where all my friends are coming over, or some shed in the back that no one's ever going to see? It's probably going to be the living room where all my friends are going to come and visit and see. Therefore, if I hold a code review for a particular module, I have a vested interest because of my pride as a developer, because of my professionalism, to make sure that that code is as professional, as well documented, or as well maintained, and as well written as I can possibly make it, because I know that my teammates are going to be looking at it. So I have an incentive, a vested interest in making sure that that code is right. So if, for all these many reasons, code reviews are a good thing, let's take it to its logical extreme and do constant code review. What does that mean? That means you have somebody sitting next to you while you're coding, constantly reviewing your code. That's the concept of pair programming. Two people sitting together, usually with 2 monitors, 2 sets of keyboards, and 2 mice, but essentially connected to the same machine or remote desktop into the same machine, so that they both see the IDE or the development environment, so they can both see the code being developed. The idea being that in a pair programming environment, you have one person who's a driver, the other person's a navigator. And the driver is the one generally doing short-term thinking. The driver is the one doing tactics. In other words, oh, I need to write a particular method that sorts this. Okay, I'll take care of that. Meanwhile, the navigator is thinking more strategic, more long-term, less granular, more less fine-grained, more granular, less granular, more in terms of like, okay, after we get this sorting done, then what do we do with this? What do we do with this flow? How do we manage this pipeline? What's the next piece of functionality to do? And then, after a period of time, say 10 minutes, 15 minutes or so, you switch. And then the person who was a driver becomes a navigator, and the person who's a navigator becomes a driver. And in so doing, it has the valuable benefit that the code is constantly being reviewed by one other person, that you know the code is going to be possibly written better because, again, you have another person right there making comments and giving you feedback and helping you get your code better, and you're doing the same thing when it's your turn. But it also has the value that you break down silos. No longer do you have this concept of, oh, I don't know, that other person coded it. I don't really know what that means. Because you paired, you're guaranteed that at least two people know about a particular module. And generally in classic pair programming, we rotate the pairs. It's never the same two people, or you rotate it, so it's not just always the same two people pairing up. You pair up in different pairs around the team at different times, working on different modules, so you cross-pollinate and get information about each of the modules or pieces of functionality of your code. It helps break down the silos. Now, it's often interesting because management hears about this and they immediately freak out, like, oh, two people working on the same piece of code? Why, that must mean I'm getting 50% of the productivity, right? Well, it certainly is true that it does hit productivity a little bit, okay? It does hit productivity a little bit in that it does, you're not having two people coding simultaneously, so therefore it does take a little bit longer to develop something. But the benefit is this: it is much more bug-free. Because you're reviewing it right away, it is much more bug-free. It is usually more performant. You generally have the total cycle time being less than if an individual developer did it. Because an individual developer, yes, may develop it quickly, but then think about the bugs and the bug fixing that needs to be done. Because pair programming encourages good programming practices, and because the code is continuously reviewed, the incidence of bugs are a lot less than in individual programming, and therefore the total cycle time from starting coding to delivering working software is actually reduced. So that's the answer to management, which is always concerned. Are we losing half our productivity? No, you are lowering your cycle time and delivering more functional, better, more bug-free code. That's pair programming. Don't worry, we're not going to go into that detail of the others. But the other things that it talks about in terms of feedback are the planning game. The planning game is, how do we plan releases? We have a release of our software. What pieces of functionality will it have? And what pieces of tech debt will we pay off during our project? So we're not just working on functionality, we're working on reducing our tech debt. With each release, we want to grab a bunch of our tech debt and get to work on it. And if you attended my last talk, it was a year ago, but on continuous integration and continuous improvement, the idea being that anytime you see something in the code that could be improved, write a story. Everyone knows, I think everyone's familiar with Agile, so we know the concept of user stories, right? So write a user story, say what you want to be improved in it, and put that in your backlog. Or use an automated tool like the analyzers I talked about in my talk, like FindBugs, or PMD, or SonarQube, or CheckStyle, or Jacoco, various analyzers that can look at your code without running it and determine the code quality and can list these issues automatically for you with each build, take them, pull them, write stories with them, and put them into your backlog. That way, with your release, you can say, not only are we going to do these, dozen or 100 feature stories, we're also going to deal with these 20 or 30 stories to improve on our tech debt. And the term I use there, the term of art in the industry, is Kaizen. It's a Japanese word for essentially continuous improvement, or improvement over time, change for the better. So with doing so, we can continuously work on our tech debt and get the feedback about our software and the pain points and make it better over time. TDD, test-driven development, above which more later. And the whole team, meaning we don't just talk dev to dev, we integrate with QA, we embed with QA. QA QA is part of us. We embed with the customers. The customer isn't just this alien concept that we hear about every 6 months. The customer is literally a presence every day, available to the team to talk to figure out what the requirements are. And by customer, XP is very clear. Customer is not the person who pays the check. The customer is the end user. The end user who uses the software needs to be the one that we consult with. Certainly check with the person who pays the check, but also check with the people who are actually using it to make sure it fits their needs. The continuous process, continuous integration, oh yes?
Yeah, on the feedback, pair programming and TDD, or even the planning game and the whole team, what, in your experience, what's the hardest one to adopt? What's the easiest one to adopt?
I'd say the planning game is probably pretty easy to adopt if you're familiar with any software development processes. We have management, we have planning for a particular release. I'd say getting the business owner to be part of the process sometimes can be a challenge, but oftentimes when you explain to them, the value is the programmers will develop to your specifications. You get to shape it rather than just being a victim 6 months later. They're often eager to come on board. What gets harder is TDD from the developer perspective, because oftentimes developers think tests are just like eating vegetables. It's like something you have to do. It's a chore. It's like, cleaning your room when you want to play games or something, right? And so when I get to TDD, I'll explain how it just requires a little bit change of mindset, and you can see why it doesn't necessarily have to be that way. The hardest thing, though, might be pair programming. Typically, I find it's not engineers who are against pair programming. Typically, engineers love the idea of pair programming. It's usually management that's a little resistant because of the whole notion of, oh no, this must mean I'm 50% productive. No way I'm going to have 2 people work on the same thing. So that often requires a little bit, or shows a little bit of resistance, which can be addressed by explaining exactly what I talked about. That while the total development time might be longer, you save a huge amount on the QA side, and thus the cycle time is greatly reduced. So what I can say, if you do find that resistance, is offer to prototype it for a particular story. Just say, you know what, for this story, it's a small story, maybe a 3-pointer, maybe we're going to do a 2-week iteration. Let's, me and a pair up on it for this iteration. Let's see how it goes. If it goes well, we can talk about maybe extending it. So offer to prototype that, and you find a lot less resistance, rather than mandating that the whole team go about it. So give that a shot.
The other benefit for management feedback for pair programming is you can bring junior developers up to speed quicker.
Good idea. That's right. Very good point. Yes, indeed, because a junior developer oftentimes might be off by himself or herself, trying their best to do something, but getting to observe a more senior programmer doing something is a wonderful way to learn. Whether or not that junior developer is the driver and getting guidance and navigation from the navigator, or whether the junior developer is navigator and actually observing the pair, the more senior person coding, and asking questions. Hey, why are you doing it this way? And getting feedback right away. So it's a wonderful way, thank you, it's a wonderful way to bring developers up to speed and break down the silos.
So from the larger picture, you want to be able to grow or mature your programmers, so you intentionally bring junior people as a leader.
You can, yes. I mean, they do have, if you read the documentation on pair programming, they say there are 3 ways. You can have senior and senior. You can have senior with junior, which has the mentoring. You can also have 2 juniors, which actually also helps with the learning curve. The thing about junior to junior is make sure you don't do that continuously, because then if they practice a non-good practice, or if they practice something incorrectly, there's no one to correct them. So it's important to rotate them.
Well, I don't want to go too far off track here, but when you test software or you evaluate it for security purposes, the HP Fortify, check marks, these are all companies that you literally give the code to, essentially an algorithm, and will come back and say, I'm looking for vulnerabilities. Because nobody can keep all the vulnerabilities of C in their head or Java.
Right.
So there's a bunch of tools now, and some of them are, yes, I reached a point in my code, I'm going to ship this thing off in an hour, get some feedback. But it's a machine. It's a good comment on security perspectives. Have you ever engaged Fortify or checkmarks or any of these vendors?
Yes, I personally have not, but my software has gone through that at the different companies that I've worked at. And so the talk I actually gave a year ago was on how to integrate those automatically into your process so that every check-in results in your code being built, your unit test being run, and then these analyzers coming in and hitting your code and trying to see what the vulnerabilities or weaknesses or performance hits are, and then listing them in a prioritized order so that your team can then surface these ideas. These vulnerabilities are surfaced, so you can then improve them continuously.
And the whole question of usability, like, I don't want to write another algorithm to check input from a user entering input because it's a classic security problem. I want something to parse it and look for it. So the senior person says, well, I know to get a library, someone from Microsoft or OWASP or someplace
Right.
to do input validation.
Exactly. So if you didn't hear, the comment was, by pair programming, you can also have junior developers hearing from senior developers, hey, let's use a library to do something rather than reinvent the wheel. Not only does it save us development time, but it also can help us do a tested, secure code as opposed to us trying to learn these lessons the hard way ourselves. Thank you for that. Okay, so we talked about the continuous process of continuous integration. Refactoring is common. You'll see what that means is oftentimes you'll create the bare minimum functionality, but then very soon you'll realize, hey, we're duplicating things, or hey, we could refactor this for more elegance or for usability, and that's the concept of refactoring. You have to have the courage to refactor, and you can have the courage to refactor because of test-driven development. Your code is thoroughly tested. Therefore, refactoring is not as dangerous as it would be, as fraught with worry and fear as it would be if you didn't have any tests for your code. And of course, incremental releases so that we're constantly delivering to the customer features at a predictable schedule so that the customer can see things improving over time. We talked about the shared understanding, the coding standards, for example, or the standards of naming conventions, or the way of how we particularly interact with the user in this particular company or this particular project or product. Collective ownership. The idea that there's no such thing. In XP, you never say, oh, that's not my job. You never say that. It's collective ownership. The team owns the product. It is fair to say, well, I didn't work on that, or I'm not as expert on it, so I can show you the person who it is, but it's never valid to say I have worked on that because of pair programming, you have ideally worked on every single module. Now, you may not be as expert on that module as somebody else, but at least you know something about it. You can speak intelligently about it. Everybody has collective ownership. We break down silos. It's that way, if somebody's hit by a bus, the whole project doesn't grind to a halt because at least the knowledge is not siloed within the head of any one individual. We always favor simple design because, again, you ain't going to need it. We only implement something if there's a need for it. So it keeps our system simple. Why is simplicity good? Because the more simple something is, the less something can go wrong. The more complex something is, the harder it is to test, and the greater the vulnerabilities that could be. And not just for bugs, but also think in terms of security violations. Think about in terms of hacking. We just, in the news today, in the news the past couple of days, has been a great hack, right? That cyber attack that's happened all around the world. Now consider, the greater the complexity of a piece of software, the greater the attack surface, the greater the surface area that could be attacked. The simpler we make something, the lower our surface area for attack. If you want to think about it, think of it as a fortress. Your code is a fortress. Every additional functionality you make in it, or every additional user interface you put into it, is another window or another door. And guess what? Doors and windows are great, but they're also a point of attack. And so the simpler we make something, the more we remove things that aren't needed, the less we open ourselves to cyber attacks, which is something that is going to be increasingly important as time goes on. And then lastly, a system metaphor. It's a complex term, but a really simple concept. System metaphor means let's use terminology so that everyone, business owners, coders, QA, everyone can understand. Meaning, if you're building a shopping application, use terminology and even use class names like shopping cart, like order, like invoice, like payment, right? If you use terminology like that in your conversations, in your documentation, in your testing, in your coding, then it makes it much simpler and much easier for everyone on the team to understand what's going on because that facilitates communication. Now, we talked about programmer welfare. We do this right. We don't have to do death marches. We do this right. We don't have to work, crazy hours just to make that deadline because so much change even at the last minute. We have a sustainable pace. And I liken that to when I was a runner. I used to be a pace group leader when I was a runner a few years ago up in San Francisco. I was at the San Francisco Road Runners Club, and one of the things they taught us when you're a pace group leader, always talk to your runners. When you're leading a group of runners on a run, always talk to them and always ensure they're talking to each other. Why? Because if you're going for, say, a 13, 15, 18-mile run, and you're able to talk in a conversational tone with the person next to you, then you're running at a sustainable pace. If you're gasping for air and going like this, you're not going to be able to make it. You cannot cross the finish line. You will collapse before you get over the finish line. So therefore, a sustainable pace is a pace that you can maintain, that a reasonable person, a non-Superman, non-Superwoman can maintain at a sustainable pace for the duration of the project and beyond. There's no point in burning out your team just to make a deadline if that team is burned out and leaves the company. What have you accomplished? Yay, you made that goal, but good luck trying to meet your future goals. So that's a very important part of XP. Coding, right? We have to have the customer accessible to us, embedded with us, so that we can daily interact with them. We need to test first, meaning, and we'll get into this in TDD, we write the test before we rewrite the code. That's right, we write the test before we write the code. The test will fail, then we implement the code. We'll get to that in a bit. One pair per module. You don't want to risk two people stepping on each other's toes or two sets of groups stepping on each other's toes. So if one piece of functionality is being worked on, one pair does that, okay? Then, optimization last. Don't optimize until the end, because premature optimization often leads to all kinds of poor design choices that leads to all kinds of grief and tears later. Optimize as late in the process as possible. And again, no overtime because of the whole idea of sustainable welfare. Testing, a very important part of XP. In fact, I would say TDD is probably one of the most important factors or activities in XP. We test code. We test all code. We prove that we tested all our code by having code coverage tools, such as, for example, Jacoco, Covertura, you might have heard of Emma, or tools like that. But use those coverage tools to show how much of your code is tested. Not just how many of your classes are tested, not just how many of your methods are tested, but how many of your branching conditions are tested. How many of your exception cases are tested. That's necessary because you need to test all your code to prove that your code works as you think it did, because otherwise you find out in production and there are tears. You also want to make sure that all tests pass prior to release. Okay? That means every time you check in your code, the system, continuous integration server, will build and test your code. It'll run all your unit tests. If any unit tests fail, the build fails, and that becomes an emergency. Everybody on the team drops what they're doing and focuses on the build break. The build should always be pristine. Never check in anything that breaks the build. Never check in a test that breaks. Never check in code that breaks a test. That means you need to run the test on your own system regularly. In fact, continuously. And I'll show you how you can do that when I get to TDD. Then, all bugs require new tests. Here's an interesting fact of XP. In XP, the notion is they really redefine bugs. A bug in extreme programming is not a flaw in logic. A bug in XP is just a test you forgot to write. Every bug that you find is a test that you need to write to ensure that you catch that failure, right? You forgot to write a test. So let's write a test, boom, we took care of it. So every bug is another test. Any bug is a test you failed to write, okay? And then acceptance tests. These are not unit tests, these are more of integration tests. These are tests that prove that the system integrates together, that a particular operation that has complex behaviors with different components all work together and all function as they should. And the reason you want to write your acceptance test is eventually you can get to the next step beyond continuous delivery, which is continuous deployment, wherein if you have enough automated tests and the software passes all the automated tests, you deliver to production automatically, meaning releases become non-events. It's as if you're just typing along with your colleague and somebody says, oh, hey, we just released to production. And you're like, oh, really? Oh, that's cool. Production releases should not be major events. They should not be earth-shaking events. They should not be requiring people to stay late or cancel their plans or get ready to stay until midnight. Production release, if you properly write the acceptance test, is automatic. And that's the ultimate goal. All right. Now, to do that, though, one of the key things that we need to do is TDD. TDD stands for test-driven development. Show of hands, who's doing TDD? Anybody? Okay. All right, great. So a few of us are doing TDD. Now, small font. Okay. TDD is an acronym for test-driven development. Apologize for the small font, but I'll go over this. It was created or rediscovered, as he calls it, in the late 90s by Kent Beck, the computer scientist we talked about before. He says he rediscovered it. Why? Because he claims he read an ancient book on computer science, an ancient book, like from decades ago, wherein the book was actually talking about programming tapes. Apparently, it would be input tapes fed in, and the computer would respond with output tapes, meaning tapes with punched holes in them, right? So ancient technology, and in that book, they said, anytime you're starting work on something, create your output tape first, then keep coding until you get your output tape to look like what you want it to be. So what does that mean? It means create the test first, and then keep coding until your code passes the test. And so that's what he, when Kent Beck rediscovered that concept, he codified it in a concept that he calls test-driven development. And the process for that is actually fairly straightforward. We first start out by writing a unit test. That unit test will fail, right? For example, if I'm writing a test for a class greeting, let's say I need to write code that says hello, right? Hello, Paul, right? That's what the code is going to do. All right, the first thing I'm going to do, am I going to write the class greeting? No, I'm going to write the class greeting test. I'm going to write the class greeting test, and I'm going to say greeting equals new greeting. Is that code going to compile? Of course not. I don't have a greeting class. Okay, then I switch, and I write the functionality to pass the test. In this case, I write the greeting class. Okay, great, I pass the test. The next step, I call a method. In my test class, I call a method on this newly created greeting object. Does that method exist? No, so the test fails. So then I go into my greeting class, and I create that method, and so on. So that's called red-green refactoring. Essentially, it gets it from the IDE, where a failing test becomes red, right? It's highlighted red. So you write the test, which turns things red because it's broken. You make it green by writing the code to pass the test. Then you go and break it again by writing another test or additional functionality that's broken again. And then you refactor as needed to get things well designed. Because initially when you do this, you'll have a lot of duplicated code and such, so refactor as needed. And then repeat. So rinse, repeat, just like shampooing. Rinse, repeat, and keep doing this. And eventually you end up with a well-tested, rigorously tested system. And again, a bug is not an error in logic, just a missing test. And this has a fascinating consequence, everyone. The fascinating consequence is that well-written tests become the documentation. Why is that important? Because, well, one way we can document is by writing paper documentation of our code. Another way is to write JavaDoc, right, or code comments. How many has ever worked with documentation or JavaDoc that's out of date or obsolete, right? Yeah, pretty much everyone. Everyone's worked with that. And why is that? Well, it's not because people are mean to us. It's, they're generally well-intentioned. They meant well. They initially created the documentation. It was very well written at the time, I'm sure. But over time, things change. Initially, this JavaDoc said this method takes 2 parameters, both ints. Well, over time, somebody said, oh no, we got to make the second parameter a float. But we never went back and changed our documentation, right? There's nothing checking our documentation. But you know what? What if we instead made it a unit test? What if we had a unit test that passes in 2 ints, and then we change it to require an int and a float? Well, the unit test, we just said, has to pass for our build to pass. So therefore, the unit test has to work for our code to even function. The unit test, therefore, becomes more of documentation than our actual comments. Now, XP does not say avoid comments. XP does not say don't do documentation. It says that unit tests or tests are the primary form of documentation. Consider that. A test has to be up to date because otherwise it'll break. Therefore, your documentation in the form of unit tests will be up to date. It is required, which means if a new developer comes on board or somebody comes on and says, hi, how do I work with this particular module? You just tell them, here you go, here are the unit tests. And by looking at the unit tests, by looking at the method names of the unit tests, they should be able to see what that means right away. Okay, what's the rationale? What's the rationale? Well, TDD, this is all from Kent Beck. TDD allows us to get focus. We implement only enough functionality to pass the test. It allows us to keep things simple, which avoids overcomplicating things, generating bad performance, and possibly increasing our attack surface and our vulnerability to hacks. It gives us API feedback. We discover pain points earlier rather. If our API is overly complex or requires us to pass in 30 objects into a constructor, well, we realize it very quickly because our test requires us to pass in 30 objects, right? The benefit of writing tests before we write our code is that we see what happens when we call our code. We become the first customers of our own code, and by doing so, we recognize the vulnerabilities and the pain points. Logic errors. We, of course, find the bugs quickly, in fact, immediately. Why is that important? Because the longer you take to fix a bug, the more it costs in terms of time, the more it costs in terms of effort, in terms of refactoring, and the more it costs in terms of money, right? The most expensive bug is a bug that's discovered by a customer. The cheapest bug is a bug that you find and fix. The best bug is a bug that you never make because you know the proper practices, right? Documentation. You document usage via tests. Ease of use. You don't need to, imagine you're doing some complex sorting or some complex algorithm. You don't need to know how that works. Just write the test. You know that, this sort of complex algorithm or something that you need to do has to give you the number 5. Okay, then write a test that expects the answer 5. You'll figure out the implementation later. So it gives you a quick way to get started quickly. Separation of concerns. We now code to the interface, and therefore we separate the implementation from the interface. We get agreement with our pairs. Both of us agree that on the precise description of the problem being solved. And lastly, we get peace of mind. How do we know that our code is okay? Why? Because my tests pass. And I don't just have like 1 or 2 tests. I have enough tests that thoroughly cover my code. And how do we do it specifically? Well, with testing, we generally want to use test harness such as JUnit. Anybody use TestNG? Anybody? Okay, one person. All right. Most of us use JUnit. Show of hands. JUnit? Okay. Seems like most of us use JUnit. I personally just played around a little bit with TestNG. Mostly use JUnit 4. Paul is cluing me into JUnit 5 is coming out shortly. It seems to be a big improvement because JUnit 4 has not been changed in many, many years. I think since Java 5, so big changes coming out with JUnit 5. But that's a test harness that allows us to do the testing. The idea behind unit testing is that we test only the class under test, meaning we only test the unit. We don't test any other dependencies. Instead, what do we do with the dependencies? We mock the dependencies, we stub the dependencies, or we spy the dependencies. Right? What are they? Anybody heard the terms mock, stub, or spy?
Mock.
Mock? Okay. Well, they're related. They're called test doubles. They come from the term stunt doubles, right? In a movie when an actor is getting in a fight or a dangerous thing, they have the actor go right to the edge, and then they yell cut, and they bring in a stunt double to do the actual, dangerous work. Well, it's the same concept in a test. What you want to do is you want to test just your class, but a non-trivial class will have other dependencies, like maybe a database object that writes to a database, or maybe a logging object that writes to a particular log, or maybe some other user interface thing that polls a user and gets the user input. Well, if your class is maybe the calculator, you don't really need to instantiate all these things in order to test your calculator. Instead, you can insert a test double, a mock, a stub, or a spy, to act to fulfill those dependencies, and then you're able to just test your code in general. Now, what does that mean? A mock object is in most of the mocking implementations that I've looked at, like PowerMock, JMock, Mockito, a mock object is a subclass of the class you are testing. It is a subclass that uses Java reflection to override all the methods in the class so that it can return whatever you want, whatever you in the test want to say. So therefore, imagine that your code under test goes to a database class and says database.write to database table. Well, you don't want to really do that because then you'll be writing to the real database table. More importantly, if the database is down or something, your unit test will fail. You don't want to fail your unit test just because the dependency failed. So instead, you create a mock, and you tell, using the mocking harness or the test harness, you say, when this mock object write to the database is called, instead I want you to return hello world, or I want you to return a hard-coded string. That way, your code can execute as if it's working with the real database connector, but in reality, it's just working with a mock object. A stub is a partially implemented object. For example, imagine your database object. A stub of that would be an in-memory database object, where the functionality is stubbed, meaning it is kind of shortchanged or basically simplified for testing purposes. And a SPI, think of it as in between. A SPI is a stub in which some of the functionality is mocked, meaning it's hard-coded to return what you want, and otherwise it actually delegates to the real functionality, the real object, the superclass essentially, to do the real work. Okay? So you can decide which of those you want to use on a per test basis. And you want to make sure you test the happy path and sad path. One of the things I see oftentimes is that the unit tests only test when things go right. And that's great. It's good to test when things go right, but it's almost more important to test what happens when things go wrong, when the inputs are out of bounds, when you're expecting some sort of number to divide by and they give you a division by 0, right? It's important to test things like that. You want to test the sad paths as well. And you use assertions to validate the behavior and the results of your code. So we talked about mock, stub, and SPI. Here it is in a little bit more detail. A mock extends an object and lets us specify the particular method behavior that we want. A stub is different from a mock in that it implements partial functionality. Again, the example I used was in-memory database for a real database. And a SPI implements some real behavior and some mock behavior, meaning we can choose what methods we want to be hard-coded and what methods we want the real code to be called. All right, and there are actually styles of test-driven development. And here's an example that I use. Let's think about the class ledger. And let's say that it has a method called calculate that takes a string. And let's say that we're passed in the string 5 times 7. Let's imagine that that ledger.calculate internally calls another class called calculator, and it calls the method multiply on calculator with the parameters 5 and 7. There are actually two ways or two styles of doing test-driven development. And they're called classic style and mockist style. Now the classic style comes from, it's often called Detroit style or Chicago style because it comes from the Kent Beck world. Remember, he was at the Chrysler Comprehensive Compensation Program, the payroll program at Chrysler in the late 90s. Chrysler is in Detroit, and this became called the Detroit School and also the Chicago School because of a group of practitioners who practiced it there. They believed in testing the results, meaning if I'm testing ledger.calculate, all I need to do is I just need to assert that the result is 35. That's all I care about. To me, it's a black box. I don't care about the internals. I just care that the functionality is there. However you implemented it, that's a black box to me. Now, there are another group of people, the London Extreme Tuesdays Club. It was a group of Agile XP practitioners in London, England, in the UK. And they got together and they realized they really wanted to practice mocking. And why did they want to practice mocking? Because they wanted to do white box testing, not black box testing. They actually wanted to look into the code and make sure it behaved the way that they wanted it to behave. And that means they tested the behavior white box using the mocks. In other words, the classic TDD for this would just validate that it returns 35, while the London school or the mockist school would actually validate that ledger.calculate calls calculate.multiply. Okay? It actually ensures that you're actually calling that particular class. And so in that fashion, we can actually ensure that the behavior that we expect is tested, not just the result. And you can choose which one makes sense. If you have simple functionality, I would suggest just do classic style. If you don't care about the complex, if it's not a complex function, you just care about the results, just do it that way. But if you have something that could fail or could be complex or you're worried about it, think about mocking it so that you can do a mockist style and so you can do white box testing and actually ensure that the methods are called with the particular parameters that you expect. And then the best practices here, we would want to continuously run these tests in an IDE. For example, Infinitest, which I was going to show. Every check-in would run and build the continuous integration build on the server, and then every CI build will run the test, and any build breaks, we should notify the developer who checked in the code that breaks, as well as the entire team, optionally, if perhaps that developer is on vacation or checked in a break and then went home or something. So that way you have as rapid a feedback loop as possible, because as we said, the earlier in phase you find an issue, the cheaper it is to fix. Do the classic Detroit, Chicago, or mockist style on a case-by-case basis. As I said, maybe simple, just do classic style. More complex, consider London style, mockist style. And then 100% code coverage is, it's a goal. It's not necessarily a requirement. There are many times when maybe 100% code coverage is more hassle than it's worth. Like for example, I don't see any value in testing a getter and a setter, especially when an IDE creates it, right? There's no real reason for that. But try to aim for that, right? If you aim for 100 and you hit 80, good. All right. And finally, what are the benefits of XP? XP benefits and empowers small teams. I haven't seen it work with more than like a dozen people, but I've read in the literature that sometimes they've tried it with as big as 40, 50 people. So apparently it works. But generally, with small teams of motivated people, it empowers them. It enables them to deal with nebulous and changing requirements. It encourages constant customer feedback, so the customer is not surprised. The last thing you want to do is deliver something to a customer 6 months later, and the customer saying, sorry, that's not what I wanted. But by having constant customer feedback and interaction, we prevent that. We document and we code the minimum necessary. We document the minimum necessary, we code the minimum necessary, and tests serve as a primary documentation. We break silos. We implement, we encourage shared ownership because everyone is familiar with the code. We sustainably deliver incrementally more functionality so that each iteration or each sprint, we're continuously delivering better functionality, more bug fixes, more features, so the customer can see the code essentially growing before their eyes, the product growing before their eyes. This allows us to continuously improve not only ourselves, but the team, and become eventually a learning organization. And that finally enables us to deal with what I was talking about as the theme of my talk, which is to thrive amidst constant change. Thank you very much. We're going to do a break, and then we'll get back.